Good morning, grade 8. We're going to continue our lesson that we have started yesterday, chapter 10, lesson 1 in Algebra 1, organizing and displaying data. We learned the bar graph and the double bar graph and the line graph and the double line graph. Today we're going to learn the circle graphs. So page 688. Reading and interpreting circle graphs. Okay, use the graph to answer each question. I have here a circle graph, okay? Circle graph shows Phoebe's fruit salad recipe. Phoebe fruit salad recipe. So, the fruit salad consists of many fruits, okay? So the circle graph here shows each ingredient, what shows the part of each ingredient in the salad. So the kiwi is here half, and the blueberry is 1C, and the banana is 2C, and the strawberry is 2C, and the cantaloupe is 2.5C. Okay, let's read here. A circle graph shows parts of a whole. Parts of a whole, as we see here, each component or each ingredient for the fruit salad is apart from the whole, fruit salad. So the circle graph shows parts of a whole. The entire circle represents 100% of the data, and each sector represents a percent of the total. So each sector here, each part here is called sector. So each sector here represents part of a whole, part of the whole. The kiwi is part from the whole fruit salad, from the whole circle. Blueberry is a part from the whole circle. Circle graphs are good for comparing each category of data to the whole set. Okay, girls? So, use the graph to answer each question. Which two fruits together make up half of the fruit salad? So I'm going to search for two only fruits that make half of the fruit salad, since the whole circle represents the whole fruit salad. So I'm searching for two sectors that make half of them. So look for the two fruits that together make up half of the circle. Is it the cantaloupe and the strawberry? No. Is it the blueberry and the banana? No, they are not complete. Let me draw here. If I will choose here the cantaloupe and the strawberry, it doesn't show a half. If I will take the blueberry and the banana, no, it doesn't show a half. If I will take the kiwi and the blueberry, of course, it doesn't show a half. So, it is the banana and the strawberry. You see, girls, the banana and the strawberry together make half of the circle, make half of the fruit salad. So bananas and strawberries. Okay, girls? B, which fruit is used more than any other? Which fruit is used more than any other? So I will search for the greatest part. Used more. More means I used it the most. Greatest. amount I used it. Is it the kiwi? No, of course no, because the kiwi is the least amount that I used. It is the cantaloupe. The cantaloupe. Why? Because as you see, it is the greatest amount. And also, as you see, it is the greatest number here. Oh, half, 1, 2, and 2, and this one is 2.5. Okay, girls? So let's watch here.
Okay, so we're making a fruit salad, and we're going to use a bunch of different types of fruits.
Girls, you're watching the video, right?
Yes, it's clear.
We're going to use honeydew, we're going to use some kiwi, grapes, raspberries, banana, and this is the amounts that we're going to use. And it turns out that these amounts can be produced to make a pie chart. Now this is a pie chart which shows sort of the various proportions of the entire whole that we are actually using in order to make this fruit salad. Now using this pie chart and this pie chart alone, without even looking at the values, we can actually answer some questions. Let's check this one out. Which 3 fruits together make up half the fruit salad? All right, which 3 fruits together? Well, without even looking at the numbers, we can just visually take a look at this pie chart and ask, well, which 3 fruits together make up half of the circle? Well, you can see this looks like a diameter to me, and there are these 3 fruits right here that add up to that half. So the answer would be, without doing any arithmetic, honeydew, kiwi, and grapes. And there you have it. Let's take a look at a follow-up question. Which fruit is used more than any other fruit? Well, here I'm asking for which is the largest piece of the pie, which can be easily seen to be the bananas. And so, in fact, the answer is bananas because that's the biggest sector. That's the biggest sector. Neat. Again, a pie chart is a great way of seeing data when you want to compare various categories to the whole.
Okay, girls, so back to our book. Next page, please. The next part is choosing and creating an appropriate display. You will be given a table. This table contains a data, and they want you to choose by yourself. You're going to choose whether to represent this data by bar graph or by line graph or by circle graph. Okay, girls, you're going to choose by yourself. Okay, I will start by B. Okay, then I will go to A. B. Okay, division of crops. The crop: corn, fallow, mixed vegetables, soybeans, and wheat. So, and the area of them. So it is the same like the fruit salad, right? So which one do you think it will be better, the bar graph or the circle graph or the line graph? I feel that it will be the circle graph is better. A circle graph is appropriate for this data because it shows categories as a part of a whole. When I find part of a whole, I choose the circle graph. When I am looking at a table and I find parts of a whole, so it is better to choose the circle graph. It is better to choose the circle graph. Sometimes you will find like the attendance of the students in the school, like the favorite fruits for the students, like the favorite sports for the students in school, like the change of weather during the whole month, during the whole year. You see the kinds of data that you will find. The change of weather and the kinds of fruits and the favorite sport and so on, and all of them, they are not categories. They are not parts of a whole. They are not parts of a whole. Change of weather during the whole year is not a part of a whole, right? But making a recipe and finding which part is bigger than the other and so on is a part of a whole. So it's better to choose a circle graph. So in example B, it is better to choose a circle graph. So a circle graph is appropriate for this data because it shows categories as parts of a whole. How I'm going to draw the circle, how I'm going to do everything in the circle graph. Just follow the steps here. Step 1, calculate the percent of the total represented by each category. Calculate the percent of the total represented by each category. Part and total. So first of all, I have to calculate the total. What is the total here? The total here is, let me write, 70 plus 50 plus 10 plus 40 plus 30. 70 plus 50 plus 10 plus 40 plus 30, all of them makes 200. So here I got the total. Here I got the total. I got the total because the corn is a part of the total and the fallow is part of the total and the mixed vegetables part of the total. Where is the total? The total, I'm going to add all the components together. Okay, so after adding 70 and 50 and 10 and 40 and 30, they are all 200. Okay, girls, if you're going to follow all the steps, step 1 and 2 and 3, you will be able to draw a circle graph. Okay, so now I'm going to calculate the percent of the total represented by each category. The corn is 70 over 200. 70 over 200 is 0.35. If I will make it by percent, it will be 35%. If I will keep it as a decimal, it will be 0.35. Soybeans, so it will be 40 over 200. So when I simplify it, it will be 4 over 20. When I simplify it more, it will be 0.2. Okay, girls, don't leave it as a fraction. It is better to change it to decimal. So it will be 20%. 0.2 is equal to 20%. Fallow, it is 50 over 200. So it is equal to 0.25, which is 25%. Then 30 over 200, so it is equal to 0.15, which is 15%. Mixed vegetables, 10 over 200, so it is 0.05, which is 5%. So now I calculated the percent of each category from the total. Step 2, find the angle measure of each sector. Because I got everything, how I will draw this part is greater than this part, which one is the greatest? Yes, I know which one is the greatest and I know which one is the least, but how I will distribute it in the circle, how I will distribute it in the circle. Step 2 is the most important step because you will learn how to distribute each sector. Step 2, find the angle measure for each sector of the graph. How I will find it? Since there are 360 degrees in a circle, 360, look here, this is all 360. Okay, in a circle, multiply each percent by 360. So the corn is 0.35 multiplied by 360. So I got 126 degrees. Fallow is 0.25 multiplied by 360. So I got 90. Then 0.05 multiplied by 360. I got 18. 0.2 multiplied by 360. So I got 72. 0.15 multiplied by 360. I got 54 degrees. Okay, girls, this step 2 is the most important step. After calculating the percent for each ingredient or for each component, I take each percent and I multiply it by 360. each decimal here, each number that has the decimal, each decimal number I multiplied by 360. Why 360? Because 360 is the whole angle, and 0.35 is apart from the 360 angle. I want to know this part is how many in the angle. It will be how many angles? Again, 360 is the whole angle, and I know that it is 0.35. The chord is 0.35 from the angle. I want to translate or convert it to angles. How I'm going to transfer or to convert this number to angles? I'm going to multiply it by the whole angle. The whole angle is 360. So take each decimal number here and multiply it by 360. You will get its angle, 360 degrees. When you multiply the part by the whole angle, you will get its own angle. When you take each part, multiply it by the whole angle, you will get its own angle. So now I get its own angle, every angle. How I am going to draw? How I am going to draw? Okay. Here. Okay, step 3. Use a compass to draw a circle. You know the compass? The tool that I use to draw the circle. Mark the center and use a straight edge. Straight edge is a ruler. To draw one radius. Then use a protractor to draw each central angle. Girls, you're going to bring a compass to draw the circle. You know, you put here the center of the compass and draw a circle, any circle with any radius. Okay? Then use a straight edge, which is a ruler. Let me make it for you like this. I'm going to draw a circle. Okay, like this, using my compass. And here is the center, for example. Okay, girls? So I get the compass. I put here the pin of the compass and I draw my circle. Then use a straight edge, use the ruler to draw one radius, like this one. This is the radius. Okay, girls? Then use a protractor to draw each central angle. Then I'm going from here to draw each central angle. I will start, for example, by the corn, which is 126. I will put my protractor here and I will make angle 126. 126 is an obtuse angle, so it will be like this here. Then from this point also, okay, girls, I'm going to draw the fellow. Okay, it is 25, so it will be smaller, it will be acute. And then the mixed vegetables, then the soybeans, and here I got it. So to draw the circle graph, you must have compass and protractor and follow the 3 steps. If you follow the 3 steps, it will be so easy for you to complete the circle graph. Okay, girls? Let's go back to A, 6A. Use the given data to make a graph. Explain why you choose the type of graph. I have 3 types: bar graphs, line graphs, circle graphs. So, a bar graph, here I have livestock show entries. The animal, chicken, goat, horse, pig, and sheep, and its number. Okay? This one is better to choose the bar graph. a bar graph is appropriate for this data because it will be a good way to compare categories. I have here categories and I want to compare them. So when I want to compare any categories, I will choose a bar graph. So if I have parts of a whole, I will choose circle graph. If I want to compare categories, I'm going to choose the bar graph. Step 1, determine an appropriate scale and interval. The scale must include all of the data values. The scale is separated into equal parts called intervals. So here I have 38, 10, 32, 12, and 25. So which scale I'm going to use? I can skip count by 2 or skip count by 5. Skip count by 4 or by here in the chart, they skip count by 8. Yes, by 8 because 8 is also good. So here in the chart, you will choose by yourself. You will decide by yourself which scale you're going to use. You want to skip count by 2, by 4, by 8, by 5, by 10, whatever you want, choose. So in the chart here, they skip count by 8. 0, 8, 16, 24, 32, and then it will be 40. So I draw the vertical line, and for the horizontal line, I will leave spaces equal between each other. It is called intervals. I will leave equal spaces between each other to draw the bars, okay? And all the bars should be equal, not a bar is bigger than the other bar, a bar is smaller than the other bar. All the bars are equal to each other. Okay, girls? Then I will start, and the distance between each bar and the other is equal to the other one. Okay, this is called interval. For example, do not start from here. Okay, and leave a big distance. You see the distance from here to here is smaller than the distance from here to here. Now all the distance should be equal to each other. All the distance should be equal to each other. Okay, girls? And all the bar graph, all the bars must have the same width. Okay, girls? No one is bigger, like I will not draw one bigger like this and one thinner like this. No, all must be the same width. Okay, girls? Then determine an appropriate scale. We have finished. Step 2, use the data to determine the length of the bars. Draw bars of equal width. The bars should not touch. Don't draw them touching each other like this. Okay? Leave a space and the spaces should be equal. Step 3, title the graph and label the horizontal and vertical scales. The graph is what here? Livestock show entries. So I'm going to write up here livestock show entries. And here I'm going to write the animal. And here I'm going to write the animals. And here I'm going to write the number. And then I'm going to plot the graph. Okay, girls? Let's watch together here.
All right, let's take a look at some data and see how we can express it graphically. Here I'm showing some data that shows a movie shown at a theater in one year, the different types of movies, and the number of movies that went through. So there are 15 comedies, 20 dramas, 10 horror films, and 5 documentaries. So there was a total, if you add them all up, of 50.
Okay, girls, you can see it, right?
Yes.
Yes, okay.
50 movies that year. Now, how can we represent this data, and why would we want to represent it each of the different ways? Well, we can actually just make a bar chart, which just sort of shows everything together. So the number of movies and then the different categories. And so you can see here, comedy 15, drama 20, horror 10, and documentary 5. So this is a nice way of representing things. Why would you want to represent things this way? Well, it's a good way to compare the categories. You can instantly see which is the most popular one in terms of the one that appeared, the kind of film that appeared more often than any other type of film. That was drama, followed quickly by comedy, then by horror, and then by documentary. So you can read that off really fast. Now, what about a pie chart? Well, we can actually produce a pie chart, which would look like this. And you can actually find this pie chart exactly by just looking at what percentage each of these are from the total. There's a total of 50 films. And so what does that mean? For example, if there are 50 films, 5, well, 5 is what percent of 50 is 5? Well, 10%. So we have a 10% sector here for that. Whereas the horror films is 10, that's actually 20%. So that's 20% of the whole pie. And similarly for all of these, the drama is 20. So what is 20 over 50? Well, that's going to be 0.4 or 40%, and so on with the comedy. So we can actually produce this. Why would you want to look at a pie chart? Well, a pie chart is sort of nice because it shows the categories as part of the whole. So you can see here are all the movies that were shown, and you can see that, in fact, the drama made up a good bit of it, more than a third of it. So this is a great way to actually take a look at data sometimes as well. Now, finally, let's take a look at the following data set. Bailey College enrollment for the various years, and this is the various student numbers. And now to graph this, I'm just going to graph it with a line graph. Now, why would I do that? Well, because you see, the thing is, this allows us to see the change in enrollment over the various periods of time. And so I can see that, in fact, we have this sort of increase in enrollment, and that's sort of visible by seeing the line moving up. So here, a line graph is a powerful way of actually expressing this particular data set. Lots of different data out there in our lives and in the world, and our mission is to parse that information and make meaning of the data. And quite often, the best way to make meaning of the data is to actually visualize it in some sort of visual way, graphically. Once we do that, all of a sudden, pattern and structure come into focus. Enjoy thinking about the data in your life, and I'll see you soon.
Okay, girls. Let's go to the last page of this lesson. C. Use the given data to make a graph. Explain why you choose the type of graph. Choosing college enrollment in a college, year 1930, year 1955, year 1980, year 2005, and each student's, the enrollment for each student. A line graph is appropriate for this data because it will show the change in enrollment over a period of time. So, when you're going to decide which graph you're going to use, if there is a change like increase or decrease or like this, it is better to choose a line graph. If you are comparing categories together, so it's better to choose a bar graph. If there are parts, components, ingredients, parts from a whole, so it is better to choose circle graph. So here you have a line graph is appropriate for this data because it will show the change in enrollment over a period of time. Step 1, determine the scale and intervals for each set of data. Time should be plotted on the horizontal axis because it is independent. I will put down the time because it is independent, okay? Step 2, plot a point for each pair of values, then connect the points using line segments. And step 3, don't forget the title. Title the graph and label the horizontal and vertical scales. The title of the graph is Chilling College Enrollment, and the horizontal is year and the vertical is students. So here I have, I will put on the horizontal scale the year, okay, and as you see here, I have a constant space between each square here, between each rectangle. And then I will choose the scale that I will use here. Let's see the enrollment. The greatest one here is 21,650. So what about choosing skip count by 5,000? So it is 0, 5,000, 10,000, 15,000, 20,000. And then I will put 25,000. Then for the years, then I'm going to plot the year 1930. It is so small here between 5,000 and 0. Then 1955, it is also, I didn't reach even half of the distance between 0 and 5,000, which is 2,500. Then there is a clear increase here. You see the slope here, girls? This slope and this one is the greatest slope. This slope is greatest than this one because there is a big change from the fees or from the enrollment. It's from 2,000 to 15,000. There is a clear jump. I used to pay 2,000, now I will pay 15,000. There is a clear jump. So I'm going to plot it here. Then there is an increase. Yes, there is, but it is not that big like the increase happened here. Okay, girls, our lesson has ended, so I hope that you got the point, and don't forget to answer the homework of today. See you tomorrow, girls. Goodbye.